All right, today we're going to get our hands dirty with a project that, honestly, every electronics hobbyist should try at some point. We're going to connect a temperature and humidity sensor to an ESP32 microcontroller and start pulling in some real-world data. So let's just dive right in.
So, have you ever thought about building your very own weather station? Something that tells you exactly what the conditions are in your room, or your workshop, or maybe even out in the garden? Well, that whole journey starts with one simple sensor, and that is exactly what we're going to tackle today.
The very first step, the absolute foundation of it all, is measuring the environment around you. We're going to be using the super popular DHT sensor to capture both temperature and humidity, which is pretty much the starting block for any kind of environmental monitoring project you can dream up. Okay, so let's meet the stars of our show. In one corner, we have the mighty ESP32. This thing is an absolute powerhouse of a microcontroller. And in the other corner, we've got our sensor for today, the simple but really effective DHT sensor. Now, you'll see we're using the blue DHT11 model for this explainer, but you've probably also seen this white DHT22 version floating around. And if that's the one you have, don't even worry about it. The great news is the wiring, the code, everything we're about to do, it works exactly the same for both. The sensor itself is it's beautifully simple. There are only 3 pins we need to worry about. The one with the minus sign, that's our ground. Easy enough. The one labeled VCC, that's for power. And then there's S, the all-important signal pin. That's the one that's going to send all the juicy data over to our ESP32. All right, so we know the hardware, we know what the pins do. Now for the fun part, actually connecting them. Let's get this sensor wired up to the ESP32 board. And honestly, the wiring could not be simpler. It's just 3 little connections. First up, you're going to connect that minus pin on the sensor to any pin labeled GND, or ground, on the ESP32. Next, the VCC pin goes to a 3.3 or 5-volt pin. That's for its power. And finally, the signal pin, that S pin, connects to what we call a GPIO pin. We're going to use GPIO 26 for this project. That's it.
And just like that, our circuit is complete. The hardware side of things, done. Now, let's switch gears and head over to the software. It's time to write the code that's going to bring this whole thing to life. Okay, first things first, we need a little bit of help from something called a library. Think of it as pre-written code that does all the heavy lifting so we don't have to. It makes our job way, way easier. So just open up your Arduino IDE, go to the library manager, and search for the DHT sensor library. Find it, click install, and you're good to go. So the very first line in our code is going to be this one. This #include command is basically us telling our program, hey, remember that cool DHT library we just installed? I want to use all the tools inside it. It's like grabbing your toolkit before you start a job.
Okay, this next line is super important. This is where we actually set up our sensor in the code. We're creating a DHT object. We'll just call it DHT to keep things simple. And we have to give it 2 critical pieces of info. First, that our signal pin is connected to pin 26, and second, that we're using the DHT11 type of sensor. Easy. All right, moving on to our setup function. Now, this is the code that only runs once, right when the ESP32 boots up. We've got 2 commands here. DHT.begin is like the on switch for the sensor. It wakes it up and gets it ready. Then serial.begin opens up the serial monitor, which is just a little window where we're going to see all our temperature and humidity readings pop up. Here's a pro tip. It's a really good idea to add a 2-second delay right after you initialize the sensor. Why? Well, it just gives the DHT a moment to wake up and stabilize after it gets power. This helps make sure that very first reading you get is a good, accurate one. Okay, our setup is totally done. Now we get to the main event, the main loop of the program. This is the part of the code that's just going to run over and over and over again, constantly grabbing those measurements from the world around it. And you're not going to believe how easy it is to read the data. Seriously. To get the temperature in Celsius, you just call dht.readTemperature. And to get the relative humidity as a percentage, you call dht.readHumidity. We'll just stash those values in some variables, maybe call them temp and humidity. That's literally all there is to it. So once you upload the code and pop open that serial monitor, you're going to see it. A live feed of data streaming directly from your sensor. It'll update every couple of seconds, showing you exactly what the temperature and humidity are. At this point, congratulations, you are officially monitoring your environment. So let's just do a super quick recap of the whole thing, right? When you boil it all down, it's really just 3 main steps. 1, you make those 3 simple wire connections. 2,
you install that handy DHT sensor library. And 3, you use those 2 simple commands, read temperature and read humidity, to pull in the data. That's the whole project in a nutshell.
And that pretty much wraps up this explainer. You've successfully hooked up a sensor and you're reading local data, which is awesome. But just think about this for a second. The ESP32 has Wi-Fi built right in. So what if you could take this to the next level? What if you built a little web server so you could check that temperature from your phone, from anywhere in the world? Maybe something for a future explainer. Thanks for tuning in.